Well, hello and happy St. Patrick's Day. So I've had a request to look at a couple of the problems that are due this week, and it's solving fractional equations. So if you notice here, I have an equation, and you can see that in the denominator I have a variable. So then that makes this a rational equation. Okay? Now before I continue in solving this rational equation, I must identify any restrictions. So a restriction would be when in the denominator you have a 0, because we know that you cannot divide by 0. Ugh, and I don't like this pen tip. I hope to buy a new stylus soon to make this much simpler. So anyways, back to the subject. So I'm going to look at the denominators in both rational expressions. And I know y minus 3 cannot equal 0. Y minus 3 is not able to equal 0. So then therefore y cannot equal 3. Now if we look at the second denominator, that's y squared minus 9 cannot equal 0. Well, this is not a linear equation because the exponent of the variable is 2. We know then this is a quadratic, and we've learned that to solve quadratic equations we use a zero product property. Now since it's already equal to 0, I go to the next step, which is product, and I recognize this to be a difference of two squares, y plus 3 and y minus 3 cannot equal 0. And then the property part states that if I have a product of two numbers that equals 0, therefore at least one of them is 0. So either the y plus 3 would be equal to 0 or the y minus 3 equal to 0. So therefore y cannot equal a negative 3 and y could not equal a 3. Because if it were either a negative 3 or a 3, if I substituted that back into the original problem, so if we put a 3 there, 3 minus 3 is 0, cannot have a 0 denominator. If I put a 3 there, 3 squared is 9, minus 9 is 0. Or a negative 3 squared is 9, minus 9 equals 0. So therefore, our restrictions are y cannot equal 0, and y cannot equal 3, and y cannot equal a negative 3. Okay? So now let's continue in solving this rational equation. Now in solving this, I could, since it's a proportion, I could cross multiply and then set it equal to 0. So why don't I do that? So the product of the first two terms, 1 times y squared minus 9, is just y squared minus 9, is equal to 6 times the quantity y minus 3. So I'm going to distribute on the right side of the equation, y squared minus 9 is equal to 6y minus 18. Now I notice that this is a quadratic equation because when I look at the greatest exponent of the variable, it is squared. So to solve a quadratic equation, I set it equal to 0. So I'll have y squared, the stylus is not very good, minus 9 minus 6y plus 18 is equal to 0. Combine like terms, y squared minus 6y plus 9 is equal to 0. So now I've set it equal to 0. Now we must factor. So I ask myself, what times what is y squared? Well, it's y and y. And what multiples of a positive 9 equal a negative 6? Well, since it's a positive 9 adding up to a negative, we know it must be a negative, negative, and 3 and 3. Therefore, when I set both of those equals to 0, I get that my solution to this problem is y equals 3. But hold the boat! If we look over to the right-hand side, we see that y cannot equal 3. So therefore, the solution to this problem is there is no real number solution. Okay? So no solution. Whoops, I'm sorry. I don't know why I'm writing that. Okay. I hope that helps with 25. Now let's go on and take a look at. So 29, we're given this problem. 1 equals 3 over the quantity y plus 2 plus the quantity 1 over y minus 2. Now my first thing I observe is once again I have a rational equation because when I look in the denominator there's a variable in the denominator. So first thing I must do is establish my restrictions. Okay? Restrictions. And so here I know that y plus 2, the denominator cannot equal 0. Therefore, y cannot equal negative 2. And then the other denominator is y minus 2. and that cannot equal 0, because if we have a 0 in the denominator, the function would be undefined. So these are the two restrictions on this equation. Now, it is a fractional equation. There are a couple different ways I could do. I could make everything have the same denominator, and then set the numerators equal, or I can use fraction busters, who you going to call? Fraction busters. Okay, and that's typically the method I will use. So I'll notice the common denominator here. So the LCD for this problem is you look at each denominator and multiply the factors. So it would be y plus 2 times the quantity y minus 2. So I'm going to multiply every single term by y plus 2 times the quantity y minus 2. Y plus 2 times the quantity y minus 2. And then again, I'll multiply 1 by y plus 2 times the quantity y minus 2. Phew! Okay, so now let's reduce. So in the left-hand side, I have 1 times y plus 2 times the quantity y minus 2 is equal. Now notice the y plus 2's will reduce, so I'm left with 3 times the quantity y minus 2. And then in the second expression, the y minus 2 will reduce, so it's plus a 1 times the quantity y plus 2. Now I'm going to solve this equation. So first thing is I'm going to distribute. So here I notice I'll get y squared, and then it's plus 2y minus 2y. So that makes it 0, and it's minus 4, because we recognize that to be the difference of two squares. And then I have 3y minus 6 plus y plus 2. So again, you ask yourself, what type of an equation is this? Well, since the highest degree of the variable is a 2, this is a quadratic equation. And we know that our method for solving a quadratic equation at this point is a zero product property. So I'm going to set it equal to 0. But you know what, before I do that, I'm going to combine some like terms to make it a little bit simpler. So 3y plus y is 4y. Negative 6 plus 2 is negative 4. So now I'm going to set it equal to 0. So I'll have y squared, subtract a 4y, negative 4, and then I'm going to add the 4 is equal to 0. Okay, combine like terms. Y squared minus 4y equal to 0. So I've set it equal to 0. Now product means write it in factored form. And when I look at this expression, first step of factoring is there a GCF? Yes, there is. It's y times the quantity y minus 4 is equal to 0. That's a minus. Okay, and then the last step of the zero product property, you set each factor equal to 0. So therefore I'd have y equal to 0, and then I would have also y is equal to 4. So it looks like my two solutions to this rational equation are 0 and 4. I hope this helps you in understanding the concept.